Hello guys, this is CodeNCode and this is video editorial for the problem Koko eating bananas taken from Leetcode. So the problem is there is a person there is a person Koko, and there are n piles of banana. Each pile is having piles of I bananas. Basically piles is an array and ith index contains the size of the ith pile. Now the guard has gone for h hours and we have to decide the speed, the banana eating speed. That would be k. So that guy would start eating the banana one by the piles he would start eating one by one, and suppose the speed, basically he needs to finish all of the bananas from all of the piles in less than equals to h hours, because the guard has gone for h hours and he needs to finish this eating all of the bananas in less than equals to h hours, and we have to find the minimum speed. Now let me explain with an example what speed it is. Now here you can see this is the size of each pile. Now h is equals to 8, that means we have 8 hours to finish all of the bananas. Now if I keep the speed 6, it will take 1 hour to finish the first pile, because the size of the first pile is 3. Speed of mine is eating 6 banana per hour, so of course I'll finish eating the first pile in less than 1 hour. But even if the guy completes eating the banana before the time has completed, before the integral time, here it would take only half hour to complete eating this pile. But the problem is he needs to wait for the completion till the integer point. So even it's 0.5 hour, he will stay there till 1 hour. So it would take 1 hour to finish this pile, then he will move on to second pile will take 1 hour, because remember we have chosen speed to be 6. Okay, so 1 hour here, 1 hour here. Here he would take 2 hours. First hour to finish 6 bananas. Now he's left with 1 banana. Again he would eat 1 banana and wait for the rest of the time to be 2. Wait for 2 hours to complete, because of course the integral time span. So basically you need to find size of the total time taken would be size of the pile divided by speed, and you have to take seal of it. And I am assuming that you already know seal and 4. So 7 by 6 would be 1 point something, and 1 point something, if you take the seal of it, it would be converted to 2. So if speed is 6, it would take 1 hour, 1 hour, 2 hour and 2 hours. So in total it would require 6 hours to finish 2 4 2, yeah, it would require 6 hours to finish the whole piles, the complete piles of bananas. So in 6 hours he is able to completely eat all of the banana, and 6 is less than equals to 8, so speed 6 is valid, but we want minimum. So output, as you can see, is 4. So let's see what happens, how much time it takes if we keep the speed to 4. See, 3 by 4, if you take seal of it, it is 1. Here it will 2, and 1 and 2 3. So here it is 2 again, so 3 and 2 5, and here it is 3. So in total 8. So it is taking when you keep the speed 4, it would take 8 hours, and 8 hours are less than equals to h, of course. So it is valid as well, valid is speed as well. And now 4 is the minimum, because if you try to evaluate this on speed 3 or 2 or 1, you won't be able to finish it in less than equals to 8 time. So we have to define the minimum speed on which we are able to completely finish all of the bananas, and the time taken is less than equals to h hours. So how we are going to solve this? Of course we are going to solve this using binary search. And if you have watched the lecture series in which I have taught you guys binary search, I have already explained there that we need a monotonic function to work with on binary search, right? So of course we need to define a monotonic function, and we need to first prove that this is a monotonic function. So first thing is, let's define a function f of x. F of x returns the number of hours it would take to eat all of the bananas with speed x. Okay, so this is the function. Now for example, if if these were the piles of banana and your speed was 5, it will require 19 hours to finish all of these bananas. You can go and count, complete it. Now task to you is to prove that the function f, this function, is actually monotonic function. To prove why I'm asking you to prove this monotonic, because we will be using this function to solve or to apply binary search on, and we'll be applying binary search on speed, and we'll utilize this function to solve the problem. Now since we are utilizing this function must be monotonic, as explained in the lecture series where I was teaching binary search. So if you have not watched those videos, I would highly advise you to watch those videos, otherwise you are good to go. Now the task I'm leaving it to you, to prove that the function fx is actually monotonic. And how you can prove this? Well, since the function let's f of x is equals to k, that means with speed x it takes k hours to completely eat all of the bananas. Now if you increase the speed, current speed is x, if you increase the banana eating speed, of course the number of hours taken to completely eat all of the bananas would be less than or equal to the current speed k. So in other words, f of x plus h, where h is non-negative integer, f of x plus h is less than equals to k, which means this function is actually since we are increasing speed, this is decreasing, so this function is non-decreasing function, because it can be same or decrease. The function is non-decreasing, so of course this is a monotonic function. Now since the function that we want to work on is actually monotonic function, we can apply binary search on. So using the function fx, we'll be applying binary search on the speed, because we want to find the minimum speed, so of course it makes sense to apply binary search on speed. So L and R, the two pointers which define our range of answer. L would be 1 because the minimum speed you can keep is 1. If you keep the speed 0 or less than, you won't be able to finish eating bananas. So of course L is equals to 1, and R is equals to max of size of piles. So size of piles is given in the input, so R would be max of that. Now see, if in the input you see here the maximum size of a pile is 30, so R would be 30. Why is that so? See, this is slide 5, so here in the problem statement it is mentioned, I need to show you the constraints. Come on. So here in the constraints you can see that h, where is h? Yes, h would be greater than equals to length of the piles and can be as large as 10 to the power 9. So h will be at least size of the piles, basically n, the number of piles. So h would be at least that, so we will be given at least as many hours as there are piles. Basically for each pile we have at least 1 hour to finish. We were on slide 5 now. So if you keep the speed to the maximum of pile size, then you will be able to finish all of the piles in n hours, and number of hours they are given, h is at least n, so we'll be able to finish it. So that is why keeping maximum speed as the max of pile size would be this answer won't go beyond it, because on the maximum we will be able to finish it in less than equals to hr. That is why the maximum is chosen as r. Now after that h is given to be 6. Now we have to find the minimum speed such that we will be able to finish all of the bananas in less than equals to 6 hours. So L is equals to 1, R is equals to 30, because remember R is max, so mid is 15, so we will evaluate the function f on 15. Now see, f of 15 is 8. Yeah, initially the answer will be initialized with R, so answer is initialized with 30. Now we evaluate the function f on mid, so f of 15 comes out to be 8, which is greater than h. So of course we need to increase our banana eating speed. So basically with speed 15 we are able to finish the piles in 8 hours. Now we need to increase the speed, because 8 hours are greater than the time that is given to us, so we need to increase the banana eating speed. Now when you need to increase the banana eating speed, basically the speed from 1 to 15 is useless, because till 15 on the speed 15 we are not able to finish the time in required we are not able to finish the eating banana in required time. So of course going below the speed below 15 is useless as well. That is why the 1 to 15, the whole range from L to mid, is useless. That is why we will update the low pointer to be 15 plus 1. That is why the low pointer would be 15 plus 1, that is 16. R would not change. Now we would calculate mid again. So mid would come out to be 23, and now we evaluate the function on 23. Now on x is equals to 23, we see that f of x is less than equals to h. That means 23 is one of the possible solution. So we minimize the answer with answer is equals to minimum of answer comma 23. 23 the current speed. Since on current speed we are able to finish eating all of the bananas in less than equals to h time. That is why answer is now minimized with 23 and answer now becomes 23. Now since you are able to finish keeping the speed 23, you are able to finish eating bananas in required time. So should we check for 24, 25 dash 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 till 30? The answer is no. See, our job is to minimize the speed, banana eating speed. So if we are able to finish eating bananas with speed 23, it makes no sense to check for 24, 25 or till 30, because those are greater speed and we need to minimize. So those are useless for us. That is why this time the upper pointer would be updated, because till 23 we have checked, and for 24, 25, 23 dash 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 till 30 we don't have to check. That is why R would be updated to mid minus 1 and R would become 22. Similarly, we would keep doing this, and finally we would come out of the loop where L is greater than R, and finally we will see that 23 is the solution. Now if I show you the code, this is the function f. Let's start from the main this function. Now we are provided a vector AR, the input, and H. Now L is equals to 1, R is equals to maximum of pile sizes. So max element returns the iterator to the maximum element in the provided array or list. So of course I need value, not the pointer iterator itself. That is why I'm using the value. So L is equals to 1, R is equals to maximum of all, answer is initialized with R. While L is less than equals to R, what we will do, we'll find the mid and then evaluate function f on mid. Now since AR is passed in this function, that is why I need to pass the input in the f function as well. That is why you see two things here. Now total R's taken are 0 for each element. For each pile size we would calculate the total R's taken, and that is p by mid. But since we want the ceil of it, and one way to calculate ceil is this: if you are dividing by mid, add mid minus 1 to the numerator and then divide. This would this returns, this basically evaluates to ceil. So finally we are calculating the total number of R's and then returning the total number of R taken using this speed. Now if the time taken is less than equals to h, we will update the answer and update the upper pointer. Otherwise we will update the lower pointer, and this is how you solve this problem. If you have any doubt or query, of course you can ask me in the comment section. So this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.